Okay, good evening. Welcome to
SuperMath150a.
Yeah, SuperMath150a. This might be one video, might be two videos, I'm not sure. And we're on the section on power of a point. I saw a really cool problem on Hard Problem Solving's website that sort of has to do with power of a point and sort of has to do with points of tangency. So you have a point P outside of a circle O. It intersects the circle at A and B. So the tangents from P intersect the circle at A and B. Then you have a third tangent line that intersects the circle at C and intersects the other two tangents at Q and R. Okay?
Yep.
We want to find the perimeter of triangle PQR.
Alright.
A very unusual sounding question.
Well, we don't know any of the lengths.
Right, we don't know any of the lengths. So, kind of a surprising question. What is the perimeter of that triangle?
But you can't find the perimeter. Because you have to know at least one length to find the perimeter.
Right, that's why this one's a little bit surprising. So we don't know very much in this. So we're going to try to figure out how can we make any progress on this. And I'll say for sure, this is a tough question.
Mm-hmm.
So tell me some of the things you notice in this problem.
Well, we could draw the radii to the points of tangency.
Okay, that's an interesting
Make
idea.
some right angles.
Okay, like this.
Mm-hmm.
All right.
But, we also don't know any of these angles. If we could find what this angle was, it might help us.
Yeah, but we don't know what it is. We don't know anything about it.
Well, the power of a point theorem, it's not, this squared does not equal that squared.
Oh, what does the power of a point theorem say here?
Well, it says this squared would equal something like this line, this part times that part, or this part times the whole part.
Times the whole part, yeah. And that would be for this tangent. What would it say for that tangent?
Well, it would say the same thing.
Okay.
But the tangents, well, maybe if the tangents are actually equal to each other.
Ah.
Because they're square both equals the same line.
Interesting.
So
Okay.
the tangents are indeed equal to each other.
So the power of a point theorem tells us that the tangents from a point have to be equal. So that's a very important part of this problem. That the tangent lines from a point have to be equal. So PA equals PB.
Yeah, and
So we just learned something.
Does that mean PQ equals PR?
Ah, very good question to wonder. Does PQ equal PR?
Well, but if the circle was sort of shifted, if you have it slanted,
Yeah. See,
but you could still have it slanted. You could still have it tangent and hit both lines, but it wouldn't have